Have you ever stopped to think about what's actually going on when you type on your keyboard? I mean, really, what's happening? Well, it turns out there's this fundamental language, this kind of invisible code that's been powering our digital world for over 60 years. And that code? It's called ASCII.
So let's start with a simple question. When you press the letter A on your keyboard, what does your computer actually see? It doesn't see a letter, not at all. It sees a number. So how does every single computer everywhere agree on which number means A? The answer is this brilliant, elegant standard called ASCII.
You can think of ASCII as a universal translator for machines. It's basically a dictionary that maps every key you can press, and even some that you can't, to a specific number, from 0 all the way to 127. This simple idea is what finally allowed computers to speak the same language.
Now, to really appreciate just how genius ASCII is, we need to rewind the clock a bit and understand the huge problem it was designed to solve.
At its core, ASCII is a 7-bit code. What does that mean? Well, it uses a sequence of 7 zeros and ones to represent any given character. And with 7 bits, you can create exactly 128 different combinations. That's 2 to the power of 7. It turned out to be just enough space for all the uppercase and lowercase letters, numbers, and common punctuation you'd need.
But before this simple, elegant standard came along, the digital world was, to put it lightly, an absolute mess. It was a true Tower of Digital Babel.
Just imagine this. Every early computer company was basically inventing its own secret code. You had IBM with its own set of codes, the military was using something called field data, and the old telegraph systems used something else entirely. There was just no common ground, no single standard to unite them.
And this created a massive problem. If you tried to send a message from one computer to another, there was a good chance it would just arrive as total gibberish. This lack of interoperability was a huge roadblock to progress. I mean, you couldn't build the interconnected world we have today on that kind of shaky foundation.
So, back in the early 1960s, a group of really forward-thinking engineers got together. They set out to forge a kind of Rosetta Stone for machines, a single, universal code to finally bring some order to all that chaos.
The whole journey kicked off in 1961 with a proposal from Bob Beamer at IBM. By 1963, they had the first version out. Then came a really crucial update in '67 that added lowercase letters. And believe it or not, that was a huge point of debate at the time. Then finally, in 1968, it became the official standard for the entire US government, which really cemented its place in history.
Now, one of the most interesting things was the central debate the committee had. Should the code be 7-bit or 8-bit? An 8-bit code was tempting because it could handle 256 characters. But you have to remember, data transmission was really expensive back then, so they made a super practical choice. A 7-bit code was cheaper, and, this is key, it left that 8th bit free to be used for error checking. In the end, efficiency won the day.
And this is the moment it all became official. In 1968, President Lyndon B. Johnson issued a memorandum that basically said any computer bought by the federal government had to support ASCII. That government backing was the push the industry needed, and it forced everyone to adopt the standard. Okay, but ASCII isn't just a boring list of numbers. No, it's a work of incredibly clever and intentional design. So let's dive into some of its hidden genius. Okay, take a close look at the binary codes for uppercase A and lowercase a. You see it? Do you see the pattern? They are identical, except for one single bit. And let me tell you, that was not an accident. It was a stroke of genius. Because they designed it this way, converting text from uppercase to lowercase, or back again, became a ridiculously easy operation for a computer. All it had to do was flip one bit. This simplified everything, from sorting text alphabetically to actually designing the physical hardware for keyboards. It saved a ton of time and money. Here's a fantastic little piece of history baked right into the code. ASCII code number 7 is called bell. Why? Because on old teletype machines, when the machine received that code, it would trigger a mechanism that rang an actual physical bell. It was literally the original notification sound. Have you ever wondered why on earth we have both a backspace key and a delete key? Well, ASCII has the answer. Backspace was designed for printers. It literally moved the printhead back one space. Delete, on the other hand, was for paper tape. It would punch holes in every single position of a character, basically rubbing it out. So yeah, 2 different keys for 2 very different physical actions from a bygone era. And finally, this explains a really common quirk in computing.
If you've ever sorted a list of files and seen a name starting with Z come before a name starting with A, you've just witnessed ASCII-betical order. It's simply because, in the ASCII table, the block of numbers for all the uppercase letters comes before the block for all the lowercase ones.
So at this point, you might be thinking, okay, that's some cool history, but what does it have to do with today? Well, the truth is, ASCII's legacy is all around us every single day.
For decades, ASCII was the undisputed king. It was the language of the early internet, the language of email, of everything. As you can see from this chart, it wasn't until late 2007 that a new standard, called UTF-8, finally overtook it in popularity on the web.
And that new standard is part of something called Unicode. It's the modern system that's designed to represent pretty much every character from every language in the world, plus, yeah, all the emojis you send every single day. It's this massive, globe-spanning code.
But here is the most incredible part of ASCII's legacy. Just remember this number, 128, the original number of characters in that very first ASCII set. Because here's the big reveal. The first 128 characters of that massive modern Unicode standard are bit for bit identical to the original ASCII set. ASCII was never actually replaced, it was absorbed. It became the bedrock, the foundational layer upon which our entire modern, global, emoji-filled digital world is built.
The story of ASCII is just this perfect example of how a simple, elegant standard can completely change the world. It really makes you wonder, right? What invisible standards, what seemingly small agreements being made by engineers right now will become the fundamental language that defines our world 60 years from now?